So we're going to do a little deal on what they're going to call warehouse management systems, but what it really is the computer software for managing a warehouse, much like what PPD uses, except for PPD's is homegrown, I'm pretty sure. Warehouse management system structures. So minimize storage costs while providing customer service. So you got two primary types of warehouse structures. Privately owned structures. Owning the warehouse creates a fixed cost to the company. And leased or outsourced structures, typically called public warehouses. So we use both. The plants will use a lot of leased space. PPD, I think they own almost all of their space, if not all of it.
So most of our plants are on leased land? I thought it was owned by PACCAR.
No, but the warehouses they use off-site are
Hmm,
leased. They use a lot of, they don't use a lot or as much as they used to, but they still have leased space that they put junk.
got it.
Yeah, distribution centers versus warehouses. So the warehouse is used to store materials. It's holding inventory for a single manufacturing site. So our plants use warehouses to hold material when necessary. Most of it, they use trailers in the parking lot, but it's still some of the same concept. The distribution center is what PPD uses. So building used stores and finished goods, provides quick throughput of goods, support a region. They also do some small value add in some of these. So WMS systems usually will try to optimize stocking locations with the following rules. So you want to minimize the costs and the picking, the order picking where somebody has to go around and find the right bin and pull apart so they can ship it. Maximize the space and group similar items together, ensuring constraints for safety, temperature, etc. And then the put away and pick, it's all labor, so it's all timed. So you got two different types of stocking locations. You got fixed and you got random floating. I think mostly what PPD uses is fixed, although they do use some stuff for random floating, I think. So in a fixed system, the items are stored at permanent locations. You're dedicated to hold only that item. So the problem with this is the space utilization isn't always that great, but the accuracy and knowing where the part is usually pretty high. Random and floating locations, on the other hand, are assigned based on available space. So if you got high inventory turns, it's kind of a first in, first out kind of thing where, all right, parts came in, this space is open, stick them there. But the problem is people forget where they put them. RFID, radio frequency identification, can help with the inventory accuracy, but it's not cheap. Each part has to have a tag on it. You have to have computer systems that can read it, etc. Overflow. So when you're using a fixed system, you'll use an overflow. When more inventory than expected enters the warehouse, it's a temporary location to put some of the extra. And the last in, first out needs to be used to clear these overflow spaces first. Point of use, locations that are managed visually by a Kanban, used to store goods close to the consumption area. So if a warehouse is providing assembly services, these are usually for small fasteners and stuff like that. They usually use a Kanban system. And then replenishment systems, distribution requirements planning, otherwise known as DRP, is basically MRP adapted for a distribution center. Takes individual customer demand on a set of warehouses, notice it's a set of warehouses, and projects over the next several periods of time, then uses that information to pick demand. And then put in orders and, just like an MRP system. The Kanban, same as in the factories. Inventory is replaced only when there's a demand for those goods, or it's like an order point system, but it's more of a visual thing. We got two bins. When the one bin's empty, the other bin is sized to cover the lead time until the parts get here. Inventory classifications is often classified according to the ABC system. So usually, most systems, A items are the top 20%. They generate 80% of the revenue or 80% of the cost, however you're looking at it. They're usually tightly controlled, cycle counted, and forecasted because they cost a lot. The B items are the next 30%, which generates 15% of the revenue or cost. And usually, you want these items for SMI or supplier managed inventory or vendor managed inventory. So that's the B items. And then the C items, this is half of your parts, but it only generates 5% of the revenue or the costs. And you want these things in supplier managed inventory somehow or some way. If B or C items are critical parts that are seldom used, you can adjust safety stock levels to compensate. Now we got perpetual versus periodic. So in a perpetual inventory system, it's a immediate recording of the transaction for each item. Sometimes it's called a continuous review system because the inventory status is checked after each transaction. So when you make a transaction, the inventory level is automatically adjusted. And it's constantly checking to see if it's below the order point. In a periodic system, it's done on a batch process, uses variable order up to quantities. This is what we use. And most companies will use a periodic system because the perpetual system is live, real time, and it just can drive like the buyers crazy because it's order it. No, okay, we got enough. No, go order it. No, we got enough. And it just does that whole mess. Most people will only do a periodic system and they'll batch it like every 24 hours. That seems to be plenty to get the information that you need, and you don't get this nervous up and down stuff going on. Warehouse management technology, the WMS. It's a software designed specifically for managing movement and storage of materials through the warehouse. Things like flexible location, assignment, FIFO, LIFO picking, data collection devices, which are handheld devices, reading barcodes, reasonable logic, determining picking sequences based on where the parts are at, order picking choices such as wave, batch, or zone, ability to interweave tasks such as put away. You got data collection, you got cycle counting, you got labor tracking, and then it all goes into the accounting and ERP systems. So this is what core applications look like on a warehouse management system. And I know PPDs does all of this stuff. And it's up the IBM mainframe, I think, like all their other software. It's homegrown. So it does what they needed to do. Make or buy. Organizations may believe that customizing a software system to their unique specs will be cheaper than adapting an off-the-shelf system. I don't know that PPD, if they had to do it over today, would actually write their own software. They would probably go to SAP or Oracle and adapt something because it's just cheaper to do it that way these days. So ISM though says you will make your own software, write your own software when the requirements are very specialized, and the WMS requires special integration with an existing in-house software system. You buy if you want the least expensive costs, or when a 3PL is using a system that is spread out through an existing network. Then the 3PL can be responsible for maintenance and upgrades. But you're going to need to be able to talk to your third-party logistics folks, which we would call an MSS. So if they're all using the same software. System integration can align and integrate with other business systems, labor, transportation, ERP. They pretty much all do that these days. And then when you're looking at your warehouse itself, PPD usually has a build out. I don't think they like building up, yeah, which is adding a higher roof. So building out's knocking out a wall, building up's adding a higher roof. The problem is when you add a higher roof, the shelving can only go so high. And the picking pallet lifters and all that jazz can only go so high. So that makes it kind of problematic when you go to build up versus build out. Two docks versus single dock layout. Just-in-time design requires warehouses to accept more frequent deliveries. Position the doors to allow easy access. So like you can't have your doors in a narrow alley because trying to get a semi-trailer back down there. Some of these guys are really good and they can get them in and out of there, but not everybody. Arrange the dock to accommodate trucks of all sizes, your 52-foot trailer. Dock personnel are the best judge of effectiveness of the equipment. They're sitting there watching it all day. And plan the staging area inside the dock for the material flow. So once it comes off the truck, where are you going to put it initially? Safety carries a developer reputation for unsafe operation, should be closely watched by management. And our boys and girls down on floor 2 are doing this. Security facilities need to be able to control ingress and egress, or in and out. Keep parking away from building and design the building to be difficult to penetrate or get into. Because why? Because people steal stuff out of them. PPD had a problem a few years ago, and I think they still have the problem. Not that people were stealing stuff from inside the building, but they were digging up the hot wires outside and stealing the copper. It's like, wow, the thing's live, and these guys are digging it up out of the ground and stealing it. Sanitation must consider local and government regulations regarding substances and be banned from dumping and recycling. And then material handling systems based on facility design. Warehouse usually divided into receiving, storage, and shipping areas. And some warehouses operate so that the dock areas is receiving during the morning and shipping during the afternoon. This is the old PPD warehouse in Renton used to operate this way because they only had so many docks. I think the new ones got plenty of docks, so I don't think they operate that way anymore. Especially warehouses are required for refrigeration, high value items, flammable items, hazardous material, all that kind of stuff. I don't think we do a lot with that. Forklifts, gotta look at the type and size of forklift you need. Pickers can be human or mechanized. If human, gotta have some kind of voice recognition system and computer onboard picker trucks, operator to stock equipment that brings picker to the stationary storage location. So the way most PPD works is they wear a pack and they talk into the computer, and the computer says, go to bin B7. And then they say, bin B7, I'm picking 10 of part number, da, 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 da. And the computer will say, okay, you got it right. Go to the next one. But when you're talking to the computer all day, it helps double check, especially on small parts, so you don't screw up a pick. You got things like batch pick, case pick from a pallet, pick the customer label. I think most of what we do is batch pick. And then pallets allow for efficient movement of material when using forklifts, which is why we have them. Wood is usually the cheapest, but you can't cross borders with wood pallets. They have to be fumigated. And the other issue is if you've ever been in one of our big plants, you're dumping a bunch of wood pallets in there, you can create a ton of dunnage in a very short amount of time. And we use a lot of racks for that reason, because you return them. Warehouse receiving dock where carriers have appointments, which is what PPD does. You can't just show up and unload. You got to get an appointment. And you must be able to measure and predict the workflow. Labor intensive versus mechanized. So material handling or moving stuff around the warehouse is usually done semi-manually. So for automation, we have what's called an automated storage retrieval system, or an ASAR. And this system will consolidate material in the warehouse and free up floor space. It's basically automated carousels where you stand in one position and the carousel comes around with the parts. And there's also automated guided vehicle transports. So I've seen these in the tire manufacturers because the plants are very spread out. So they got these automatic vehicles that are just kind of like square boxes on wheels that drive around and tow stuff. But these things don't create more space. They just move stuff around. You got RFID, which helps with inventory loss, but it also does not create more space. The ASAR will create more space. That's an automated conveyor system. Voice recognition results in substantial picking errors, but it doesn't create more space. There's only one thing here that creates more space. That's the ASAR system. So now the question:
would you say the ASAR is like our cab paint drying system at the plants?
Yeah, what they're talking about here is you're standing in one location, you push a button, and bin B7 comes around on a conveyor belt to you, and then you pull the parts.
Ah, okay.
Which is, kind of the way to do it, but it's pretty expensive to set that up.
Yeah.
So the question is picker to part versus part to picker. Traditional storage system require the picker to travel to the part, which is the picker to part. So you're walking all over the warehouse, finding the storage locations and pulling the parts. The part to picker is this ASAR system, carousels and conveyors. They bring the part to the picker who's standing in one location. And this is usually not a fixed system. This is usually a, what we call this? Random floating position on the ASAR. It's a random. The next bin comes up, the computer remembers where he put it. No problems. Order picking versus stock replenishment function. So order picking is for outbound. Replenishment is for inbound. Need to have a picking route in a sequence. Usually that's all generated by the software. And replenishment can be accomplished with reorder points. Most of the time it's done with MRP, which is they call DRP. A virtual warehouse versus a physical warehouse. So in a virtual warehouse, the warehouse still exists, but they're not owned by the selling organization. So it's a drop ship. Inventory shipped directly from the tier 2 supplier to the customer. The tier 1 then has a virtual warehouse. Logistics performance measures, some of these things, cost of sales, managerial salaries, direct labor, for the logistics folks to sales, logistics per unit versus budget. 4 types of budgets are used in logistics: fixed dollar, which is what we use. Flexible for seasonality. We may use some of this too, but I think most of it's fixed dollar. Zero based. Everybody says they use zero base, but they really don't. It's fixed dollar. And capital. We have capital budgets for equipment. Cost functions as a percentage of sales, productivity ratio, some other things. Inventory turns. So this is a big deal in a warehouse. Sales divided by the average inventory, which is cost of goods sold off of the income statement. And then you go to the beginning inventory and ending inventory on the balance sheet, divide by 2. That gives you your average inventory. That will give you your inventory turns. So the faster it moves, the quicker we get paid. So the higher the number. Otherwise, we must get a loan for working capital to cover when we have to pay the suppliers versus when we're getting cash. Increasing inventory turns without consideration of the impact of logistics can result in decreased profitability because now you're shipping everything by expedited freight. Here's an article from ISM on the inventory turns ratio, everything you always want to know about it, but we're afraid to ask. And this is on-time delivery metric according to ISM. Another interesting deal. I've tried to measure on-time delivery in a number of companies, maybe a dozen, and it's always been a problem. The problems you run into are maintenance problems, maintenance of the PO due dates or the EDI due dates, and maintenance of these guys shipping on time. So how do you measure the pickup and how accurate that is? And then how do you measure when it's supposed to be here and how accurate that is? There always seems to be problems in every system I've looked at trying to measure that stuff accurately, because invariably it relies on somebody, some person going in there and maintaining all these dates so they're accurate. And it just doesn't happen a lot. Late deliveries can impact the warehouse turns and the cost of conducting business. Early deliveries result in slower turns and a need for more working capital. This is why you don't want slow inventory turns. You got to get a loan. Many organizations use the ABC strategy. Again, it's the 80, 15, 50. And then scorecards. We have our scorecards for our biggest suppliers. We also have them in GPPS. How accurate they are for on-time delivery is another question. Dock utilization, put away pallets, number of case receipts per man hour. These are some of the warehouse things you can measure. Dock to stock cycle time. It's another ISM article on that, I think. Yep. Other logistic performance measure activity cost to total logistics costs. Logistics cost to industry standard and logistics resources budgeted to actual cost. There's a few different ways you can measure logistics. Process improvement action plans. So you got to determine a root cause like anything else, not just in the logistics system, and then make a plan to fix it. Continuous process improvement should be addressed. And then you got 5S is always a good thing to have in a warehouse. All right. Which of the following is most important to consider when designing a warehouse layout?
C or B?
Yeah, I think I would probably go with B. I mean, A and C are probably important, and D, but probably B is the most important. Yep, B it is. All right, one more here. Supply manager is tasked with performing a strategic analysis to identify the optimum features of a warehouse management system that will best fit the needs of the organizations. The supply manager's analysis should examine all of the following except what? Which one doesn't belong here?
D?
Yeah, I'm thinking B or D. I'd probably go with D. Let's see what these guys have to say. B. Configuration of docking platforms is tactical considerations. As such, it should not be part of the strategic analysis. Okay. You know, it's just another question I don't really agree with from ISM. All right, there's 9 questions out there. Why don't we try and do the first 5 and I'll go over answers at 2:30 unless we get done early.
Hey, I gotta drop. Sorry, I gotta 2:30. I gotta jump to, but I
All right,
got the answers
I'll-
all posted up there. So,
yeah, I'll post the answers.
all right, thanks.
Yep. All right. I've got about a minute left, so let's go over these answers real quick. Number one is alpha. There are two issues to contend with. The first is a lack of space, and the second is inaccuracy of the inventory. So you want fixed locations. Two is Charlie. Cycle counting training program is not part of the system features. Three is Bravo. The design of the loading dock is primarily concerned with flow and safety. Four is Alpha. Allowing users to update records will compromise the integrity. You only want one person updating the records. And five is Bravo. Her items in the warehouse are fast moving and her warehouse is small. She can use the overflow spaces for unexpected items. Any questions? All right, I will post the rest of these answers. So you guys want to do the other four, you can. Or the four. Talk to you tomorrow. We'll cover some more warehouse stuff.
Thanks, Rick.
Yeah, sounds good. Thanks.
Yep.